This is Algebra 1. We are talking about systems of equations word problems today. Let's go ahead and say that today is the first 3/1. Put the date on your papers. I should see all of you writing the date on your notes. March 1st. Yep, there are only 28 days in February. It is not a leap year. All right, so ways to solve.
Last year was a leap year.
Last year was not a leap year either.
The year before that
Was it?
Yeah, it was.
2018, is that divisible by 4?
Gunnar was born on the...
I thought 2016 was a leap year.
Yeah. Wait, it was.
I think 2016 was a leap year and 2018 was not. Our next leap year is next year.
Gunnar
2020 will be a leap year.
was born on a leap
Yeah, it was.
You were not born on a leap year. Also, I learned something interesting, which is sometimes, and this is only sometimes, if they didn't know when someone died, then they put the 29th of a leap year. Just to let them know that it was something that they couldn't find out. Anyway, so there are 3 ways to solve systems of linear equations. We've talked about this yesterday. We've talked about it so many days in a row. There are 3 things to do. What's one of them? Quiet raised hand. Oh, shoot. Gunnar, you hand those out also. Gunnar, yes.
I have an unrelated question.
Oh, unrelated question.
So if you were born on the 29th of a leap year, does that mean you gain 1 year every 4 years?
Theoretically, yes. So theoretically, if you are 13 years old, you are 4 years old. Theoretically. All right, Andres, what's one way to solve?
elimination.
Elimination, exactly. We'll put it here. And once you get your card, you can turn it in. What's the second way, Jenny? Substitution. And what's our third and final way, Sergio? Graphing. All right. So graphing, just to show you a picture of what's going on. Graphing, you would have some graph. Oops, that's not what I want to do. You'd have some graph, and then you'd have 2 lines that intersect or something like that. And you'd say, okay, they intersect right there. There's the answer. That's how we solve by graphing. It requires you to know the 3 different forms of graphing: slope-intercept form, point-slope form, and standard form. So graphing is a little bit hard, and it's not very precise. Even if I had the world's best artist to draw, I don't know, the world's largest graph on the ground, and they tried graphing something really hard, they still wouldn't be precise enough unless they use algebra, unless they use method 2 and 3, elimination and substitution. So graphing is good when you have a lattice point solution, an integer solution, but once you get something that has like 3/7, you don't know exactly what that is, so you have to actually use elimination or substitution. So elimination is something as simple as you add them or subtract them. So if I add them, I see y minus y is going to cancel out. So that would be elimination. I have eliminated one of the variables. Sometimes with elimination, we need to multiply one entire equation, or sometimes both of the equations by a number. You guys remember where we had to say, okay, multiply 2x and y and 12 all by 2 in order to eliminate? We would sometimes have to do that. But most of the time, or I guess some of the times, we can just add them and then they're done. We eliminate. Substitution means if x is 2y plus 1, this 2y plus 1 gets substituted inside of this x. That x has turned into 2y plus 1. That's substitution. Give me a fist of 5 how well you remember all of graphing, elimination, and substitution. How well do you remember how to do all of them?
1.0.
I love the honesty. Is that a 2 or a 4? 4? Okay. The Klingon. All right. I'm seeing an average of about 2. I see 1s and 2s, some 4s.
Gunnar.
1.
Okay. I mean, they're hard. All right. So what we're going to do is we're going to practice using elimination and substitution with word problems. So generally, when we're converting word problems into a system of linear equations, essentially we want to read basically example 1 and come up with an equation like we have up here in the top right. Somehow convert words into equations and then solve them using those 3 ways of solving. Usually the bottom 2, elimination and substitution. All right, but generally there are 3 steps to convert word problems. You need to identify the variables. Identify the variables. You get to make your own variables. You can choose x and y, you can choose a and s, you can choose whatever letters you want. You can use Greek letters up there if you want. You can choose whatever variables and know what they represent. Maybe t represents time, maybe x represents dollars. I don't know what you want to choose, but you need to identify the variables. That's usually the hardest part. And then finally, you need to create the equations. And that is also a pretty hard step. And then step 3 should be review. That doesn't mean it's easy, but it's a review of doing step 2 and 3. You're going to solve the equations. I cannot spell equations. I was going to start spelling questions or something. Then you're going to solve the equations. And usually you're going to be doing something like substitution or elimination. Questions on the procedure? All right. I need a quiet raised hand to read our example. Go for it, Jess.
Andres is 12 years older than Samantha. 3 years ago, Andres was 4 times as old as Samantha. How is Andres now?
All right. So it's a tricky question. All right, so let's do step 1. We're going to identify the variables, I should say. What's up, Andres? Are you?
Step, you have to calculate the precipitation of the square root of how much years they are.
We don't really calculate precipitation in this class. It's more of a biology question. All right, we need a variable. Who wants to come up with a variable? Are we talking about apples? Are we talking about dollars? What are we?
A for age.
We're doing age. Okay, so let's say A equals age. You can say X equals age. It doesn't have to be the first letter of the word. It can be whatever you want. I could have said S equals age. Let's try to convert this and see if we even need a second variable. So if Andres is 12 years older than Samantha, how do we say this first sentence using our variable? It is going to be plus. Yeah. Andres is. So how are we going to say Andres? Is A the age of Andres or is A the age of Samantha? We have to all come to a decision. Is A going to be age of Samantha or Andres? Or maybe we want 2 different variables. I don't know. A is going to be age of Andres. Okay, so that means if I'm converting this statement, I want to say age of Andres is. So what am I going to say in terms of variables and equations? A equals. Okay, now I know I'm basically writing the same thing. I'm now writing the equation. Here's the equation. Andres is 12 older than Samantha. So now I have 12. I need to now say older than Samantha. Is it plus or minus? It's going to be plus. Is 12 older? Plus, and then Samantha. Uh-oh. This is the age of Andres. We're going to create a new variable, S. So we're going to say S equals age of, we're just going to say Sam. Age of Samantha. So I'm going to say A is equal to 12 plus S. There it is. Make sure it doesn't look like a 5. I'm going to make it slightly curlier than I normally would. We have only converted the first sentence. We have not converted the second sentence yet. This equation represents the first sentence. So far, so good. Fist of 5. How well are you following me? If you follow me perfectly, you're at a 5. If you got lost somewhere, you're at a 3 or less. All right, good. It looks like everyone's at a 5. Okay, so from here, I need to convert the second sentence. 3 years ago, Andres was 4 times as old as Samantha. Whoa, that's hard. Oh my God, how are we going to do that? I'm going to do red. How am I going to do that?
You're going to measure the velocity of the air.
3 years ago. So what happens to Andres' age 3 years ago? What is the mathematical statement of saying, look at Andres' age 3 years ago? What am I going to say? Who still has their cards? Come on, say. Subtract. What am I going to subtract? What? A and 3. So is it going to be 3 minus A or A minus 3? There it is. A minus 3. Everyone write it down. This is the same thing as saying 3 years ago for Andres' age. 3 years ago, we have Andres. That's going to be was. This is the past tense of is. So essentially, I'm going to be writing what sign here? There it is. This is saying 3 years ago, Andres was 4 times as old as Samantha. How am I going to say that?
He's 40.
4 times as old as Samantha. Quiet raised hand. Cohen. 4s. You're really, really close. It is 4 times s. But the thing is, this is 3 years ago. So it's going to be s minus 3. And what do I do first? And this is not to Cohen. Cohen is already good. This is to anyone that wants to participate now. What goes first? Do I subtract 3 or do I multiply by 4 first? Think of it in the context of the problem. In the context of the problem, I'm 3 years ago first, and then you multiply that by 4. 3 years ago is the context of the question, and then after I'm 3 years ago, I'm now going to be 4 times less old than Andres.
3 minus...
Which happens first? Do I subtract 3 or multiply by 4? Put parentheses around it to let you know, do that first. Remember, I'm just putting parentheses because I know, looking up there at PEMDAS, order of operations going down, I first start with parentheses. So this is telling me first subtract 3. First go backwards in time 3 years, then multiply by 4. Okay, now we have a system of linear equations. What should we use, substitution or elimination? I hear some people saying substitution. Yeah, we can use substitution. I see an A is 12 plus S, so this 12 plus S is A. Let's go ahead and plug that in. So 12 plus S is A, and then I have to rewrite the rest of the problem. I just wrote down A. I need to now write down minus 3. What's going on? Minus 3 is equal to, and I could rewrite 4 times S minus 3, but we might as well distribute. We're going to have to do that anyway. Is there a quiet raised hand? Who can distribute this for us? Who can distribute 4 times S and 4 times negative 3? You want to try this, Eder? No? Who still has their card? Jenny, did you get your card in already? All right, go for it, Andres.
Okay, so it would be 4s
4S
and then negative 12.
minus 12. There it is. All right, we're running out of room, so I'm going to come back up here now. I need to simplify the left-hand side of the equal sign. I need to simplify 12 plus S minus 3. I can basically drop the parentheses. I don't need them anymore. What is 12 plus S minus 3 reduced to? What does it simplify to? Fernando?
9 plus s.
9 plus S. There it is. All you have to do is combine 12 and minus 3. The S is independent. You have to leave that by itself. And now I have, on the right-hand side, 4S minus 12. 4S minus 12. All right, I need to solve for S. What should I do to both sides? Quiet raised hand. What should I do to both sides? Go for it, Jose.
Minus s on both sides.
Let's do it. Minus S. And you're left with what?
9 equals
Ooh, careful. 4 minus 1. This is minus 1S, right?
3 minus 2.
Minus 12. There it is. All right. Almost there. What am I going to do to both sides to get that 12 away? I'm trying to now solve for S. What am I going to do to both sides? Andres has already been participating quite a bit. I'm going to try to give it to someone else. Fernando just did it like 2 steps ago. Someone else, please. Go for it, Cohen. Plus 12. Plus 12. We're running out of room. I'm going to have to come back up here. So 9 plus 12, Cohen, is... So now I have 21 is equal to 3S. That means I can divide the both sides by... You want to solve this for us, Eder? The very end. What am I going to do to both sides to get S by itself? By? Careful. The thing that's attached to S we're going to divide by. Yes. So say it all in one sentence. We're going to divide both sides. So say we're going to divide both sides. Perfect, yes. Divide both sides by 3. And we get S is finally equal to 7. All right, are we done? Why? We need to go back and plug in here Fernando say, and that's because the question was asking for Andres' age. We just found Samantha's age. Samantha is 7. We can go back and plug it into either of these equations. Oh.
3 years ago, though?
This is currently. This is the 3 years ago right here. And then this is the current age, S. So let's plug it back into this S. We can do this in our heads, right? If this S is 7, 7 plus 12 is, there it is. A equals 19. Andres was 19. So Andres is currently 19. Samantha is currently 7. All right, we're going on to example 2.
Take my hand on the table.
You know what? We don't have enough time for the second example, so what I'm going to do is we're going to cut off the lesson here, and then we're going to do only one of the 2 homework assignments that's going to be due on Monday. So go ahead and don't write a summary. Put this in your binders, open up your laptops, and work on the first homework assignment.